Hello, in this short video, I'm going to talk about how to solve the second question in the second set of sample problems for final exam. Um, the question is asking you to use 4 equal size Bezier curves to draw a circle. And I'm going to draw a circle with radius equal to 1 and a center equal to 0 and 0, which is the origin of the coordinate system. This is what I'm going to do. I'm going to create 4 separate but connected curves. One is in the first corner, which is this one. One is this one, the gray one. One is the yellow one here from in the third quarter. And the other one is this dark blue one, right? So we're going to make all of these 4 equal size pieces of a circle, each one with 4 control points. For the first quarter, the control points are here, which is at 1 and 0 here, which I'm going to call that at index 1 and at the coordinate 1 and alpha. The second one is at alpha and 1. The third one is at 0 and 1. Why this one is alpha 1? Why is this one 1 and alpha? Because they are kind of symmetric over this line, right? About the line y equal to x. So the control points, the 4 control points, should be symmetric about the line y equal x, right? The red line is y equal x. So that's why if one of them is alpha 1 and alpha, the other one should be alpha and 1. What is alpha? Alpha is unknown. We're going to calculate alpha. And then the reason I will set the y value of this 0.1 and the x value of this 0.1 is because the 3 control points here should be on the same line, and the line is equal to y equal to 1. So the line is y equals 1. And the reason is if these 3 control lines aren't on the same line, then we're going to have a problem. What's the problem? The problem is, let me get a little bit closer to this. The problem is, based on the Bezier curve properties, we will not going to have a, give me 1 second. We will not going to have a C1 continuity over here. In order to have a C1 continuity, we must have these 3 control lines, control points on the same line, right? So because this is at y equal to 1, this should have y equal to 1, this should have y equal to 1. Same story for these 3 points, because this one's x is 1, the other 2 should have the same x equal to 1. And the reason is, on a circle, there should be no point that is not derivable. In order to make every point derivable of degree 1, we must have continuity of level 1, degree 1, right? So that's why those are the values, right? So this is my assumption, right? 1 and alpha and 1. This is only for the first quarter. For the other quarter, it's going to be similar. For the other quarter, this is the first control point. For the second quarter, this is the first control point. This is the third. This is the second control point, which is at coordinates negative alpha and 1. This one is at 1 and negative alpha. This one, I'm sorry, negative 1 and alpha. This one is at negative 1 and 0. This one is at negative 1, negative alpha. This one is at negative alpha, negative 1. This one is at negative 1, 0, negative 1 alpha, negative, I'm sorry, alpha, negative 1. And this is going to be negative alpha, and I'm sorry, this one is negative 1. This one is negative alpha, I'm sorry, alpha and negative 1. This one is going to be 1 and negative alpha. So so when you specify these 2 points, the other control points would be basically determined because they're going to be symmetric values. So when you find these 2, which I have specified them with these 2 crosses, the rest will be clear, right? And because of the symmetry of the circle, there should be alpha 1 and 1 and alpha, right? So the alpha is common in these 2 points. Here is 1 and alpha, the other one is alpha 1. After we set all of these, the only unknown variable is alpha, right? We don't know what alpha is. We're going to calculate that. So one thing we know about Bezier curve is that if you have 4 control points, this is going to be your I should say coefficients or blending functions. Beziers, all the 4 Beziers are here, right? So when n is 3, k is 0, we have this blending function. When k is 1, this control function. When Bezier curve is when k is 2, this is the control function. When k is 3, this is the control function. So I shouldn't call them control function. I should call them blending functions. So we have these 4 blending functions. In order to get the value of alpha, what I want to do is I'm going to take advantage of the middle of this curve. Only focus on the first quarter and focus on the middle cell or middle point of this curve. This curve has 20 points. The middle one is this one, and this one is going to be at y equal x. That means in the middle point of the first quarter should intersect with y equal x. That means it should have the same x and y, right? And also one more thing that we know about middle point of a Bezier curve, the parametric variable should be 0.5 because the parameter of the curve starts from 0 all the way to 1. When it's 0, we draw this point. When it's 1, we draw this point. So by do a sweeping motion from the first to last point of a curve, the variable t, which is the parametric variable of a curve, starts from 0 all the way to 1, right? So when we are at the middle, this value t is going to be equal to 0.5, right? So this is going to create a nice I should say equation to find the variable alpha, right? So in order to do that, I have done this. I said I know what the blending functions are. I'm gonna use the same use the blending function for Bezier curve by setting t equal to 0.5. This is a table that changes t from 0 all the way to 1. When t is equal to 0.5, the values of these blending functions are going to be 12.5%, 37.5%, 37.5%, 12.5%. Also, I can do it in a different way. I can say all the coefficients are going to have a 1/2 cube when t is 1/2 or 0.5. So we're going to factor this out. The first one, which is the first blending function, has this value. It's going to be 3 choose 0. And this should be multiplied by the x value of the first control point, which is 1, plus 3 choose 1 times 1, which is again the x value of second point. That would be for the second blending function. For the third blending function is 3 choose 2. For the third one, for the last one is going to be 3 choose 3. Why do we multiply 3 choose 2 by alpha? Because you have to multiply the third blending function by the third point, which is the third point's x value, which is alpha, And then that's going to give us the x coordinate of the middle point. So as you have seen, this middle point, which is specified by this triangle, has the x mid equal to this. And the y mid should be this, right? Similar to the x mid, you can calculate y mid. All you need to do is, instead of using x coordinates of control points, you got to use y coordinates of the control points. What should be the goal of the middle point? What should be the coordinate of the middle point? It should be 1 over a square root of 2 and 1 over a square root of 2, because if you have a perfect circle, a perfect circle will intersect this y equal x at this point. Why this point is the intersection point between the circle and between the perfect circle and the y equal x line, because y equal x line has a slope of 1. So this angle is gonna be 45 degrees, right? And the x and y value of this angle would be cosine of 45 and sine of 45. So the cosine of 45 is this, sine of 45 is this. It's going to be 1 over 2, 1 over a square root of 2 for x, 1 over a square root of 2 for y. You have like 2 equations, but when you simplify that, it's basically 1 equation repeated twice. And when you solve that equation, you get the value for alpha. The alpha would be this, which is a little bit more than 0.5. If you find the value, it's going to be like 0.5. I have the value here. Let me show you the value. It's not going to be a hard calculation. The value alpha, I've placed it here. That's going to be the value of alpha, right? After you find out what the value of alpha is, but using this equation, all you need to do is to say the following. Say, all right, so I have the value of alpha. So I know what the coordinates of the control points are for the first quarter. For the other quarters, based on symmetry of the shape circle, you can find out the other values. And that would be all the control points. The first 4 points are for the first quarter, then the second quarter, then the second and the third quarter, then the last quarter. And then you're going to blend these control points using these blending functions for all the values t from 0 to 1. And then this is going to give you the quarter 1 xy value, quarter 2's xy value, quarter 3's xy value, quarter 4 xy value. This is already posted on Canvas. You can check it out. And after you connect them, you can just plot it, and you can see that we get a perfect square, a perfect circle for this solution. So that's the answer. Thank you and have a great day.